Hey YouTube, welcome back. Today we have interesting video. Today we will talk about 5 interviews questions about TypeScript that you should know. And yeah, the video will be quite quick. The first question. We'll start with what is. Oh, sorry. Let me copy the question again. What is TypeScript? And what are the differences between TypeScript and JavaScript? And it's a quite important question because you should know this is one of the most common questions that tells the interviewer like if you know anything about TypeScript or not. So first of all, TypeScript is a superset of JavaScript that adds static typing and other features to the language, and it is an open source programming language developed by Microsoft. TypeScript code is transpiled or converted into JavaScript, which means that TypeScript can be run on any JavaScript runtime browser. The differences, first we have, the first difference that we'll talk about, I guess I should make the font quite bigger. Let me see here. What is the settings? Font. I guess there was something here about font. Let me see. I don't know. I guess. Let me see here. Yeah. Font size. Let's make it 18. Let's see. Yeah. This is. I guess this is way more better right now. Okay. So, I will say the first one that I want to talk about is the static typing. And the static typing, TypeScript basically introduces static typing, which means that you can specify the data types on variable. So, for example, like maybe function parameters. For example, we have function parameters and return value. This helps catch the type related errors at a compile time. So, for example, we will have a function that we call great, and it takes a name parameter, and I will give it a type of a string, and also I expect the response to be string, and I will return hello name. And if the name isn't string, we know where is the error. The second thing is the second thing is the type annotation. Let me copy this because copying it will be easier than. So here, type annotation. That means in TypeScript you can add type annotations to variable and function and functional parameters to explicitly declare their types. This enhance code readability and provide documentation for developers. So, for example, we will have let age, which is number, will equals 24, for example, or 30, whatever it will be. The second thing, it's the third thing, which will be interfaces and type declaration. So here, TypeScript introduces interfaces and type declarations, which allows you to define the shape of object and custom data types. So if we find an example for that, we will have like an interface, and it will be a person, for example, and it will have name, string, age, and a number. Like name is a string and age is number. 4, we have strict null checks, and this is quite important one. 4, we have strict null checks. So here TypeScript has strict null checks which help prevent common runtime errors like null or undefined differences errors, you must explicitly handle null or undefined values in your code. So for example, we have okay, so for this one we will get an error. I love Copilot. Copilot just to make my job way more easy. So we have a string. If it's string null, it will be equals error. However, we could add string, could be string or could be null, and by this way it will not be an error. For I guess 5 we have maybe we have the enhanced the OOP support, object oriented programming support. That's me. 5 OOP support. So here TypeScript supports object-oriented programming. OOP features such as classes, interfaces, and inheritance, and access modifiers. So basically, if we have, let's create a class. So we'll have a class called animal, and this class, for example, will have an object. We'll have a constructor, and yeah, for example, it's something like that. Or is it, and we maybe have like a get name, maybe, or have like a void method, yeah, stuff like that. I guess 7, maybe we have 3 more. 7 generics. 7 will be generics. And in the TypeScript supports generics. Generics. So basically, TypeScript supports generics, allowing you to write reusable and type-safe code that works with different types of data. So, for example, we have okay. I love Copilot. It just say okay. So difference here, we have type, identity. So basically, if you can create a new like a new variable based on this function, and you set the t or the args or number, it will be number. If we pass a string, it will get an error. And we will talk about generics in a bit, but just to give me time. We want to talk about maybe, yeah, I guess that's basically it. That's mostly it about this question. Let's talk about the second question, which is what are types in TypeScript? It's an easy one. So basically, we have 5 types. So we have the basic type, which like, for example, what are types? So in TypeScript, types refers to a fundamental concept that allows you to specify the shape and behavior of the data. Types are used to enforce type checking and ensure that your code is consistent in terms of data structure and values. TypeScript provides a variety of ways to work with types, allowing you to define custom types. We use built-in types and create more complex compositions. So, for example, we have one. We will have one. It will be the basic type. It will be, for example, let age equals number, and for equals 30, and let age. What's wrong with it? Age block scope. Because we have no block const. Sorry. Let's make it var. Okay. Let's create an object. It will be the same, to be honest. Here, let's create a function here. Let's call it like function, call it yeah, let's call it type checking, or like type basic type. Let's call it basic type, and it doesn't get anything, and it returns, I don't expect it to return anything. It's just a function that we will define a block scope. So the basic type here, for example, it will be like we have age, number, and maybe we will have we can add lit if we, let's use lit. Maybe we have lit, name, it will be, yeah, Muhammad, for example, and we will have lit is married boolean, it will be false. And this is the basic type. We have custom type. Let me copy this one and go here. We have custom type, and yeah, custom type. And you can define custom types using the type and interface keywords. And this allows you to create your own data structured with specific shapes and behavior. So for example, we can create I guess I don't need to use this one. Let's just, I could create a type here. Let's call it person, and this person will be object. And duplicate. Did I duplicate? Where is the person here? Ah, yeah. Okay, let's delete this one. Okay, let's leave it. Let's leave it out. Let book. Okay, type book, and this book will have like an title, which will be a string, and maybe we have author, which will be string, and we have page, pages, and it will be number, for example. And maybe we can use interface, and I will talk about what a difference in interface and types in a bit. Not in a bit, next video actually. We have interface, and the interface I will create book, person, or let's call it animal. No, animal, we have animal. Let's call it example. And in this interface, maybe it will have also, let's name an age, for example, or human. Let's call it like that. We have type annotation, which we talked about it. Like, let me copy it. We have this is 2, and we have here 3 type annotation, which will be okay, I will just I will copy it directly here because we already talked about it. Like, type annotation, basically type annotations are used to specify the type of variable function parameters, or the return value explicitly. This helps TypeScript catch type related errors early. Okay. 4, I guess we have union and intersection types. Let me copy this one because it could be quite a lot to write them all. 4, we will have union and intersection types. And this one is TypeScript supports union types, like values that can have one or several types, and intersection types mean like combining multiple types. So let's talk about union type. So the union type will show like type result. Oh, I will have type result, and it will be equals number or string. This is called the union type. Okay, and we will have another type which called like let's call it point, which will equals for example, it has object. It could be it could be here we have object number. Okay, let's make it easier here. Let's just make it one variable, x and y. It could be x and y. It could be these two. It could be combination. So basically, the combination types, it's combining multiple types in the same time. So this is intersection type and this is union type. 5 we have type inference. So basically, type inference often, for example, let's just have this one. The type inference is often inference types automatically based on the context, reducing the need for explicitly type annotation. So for example, maybe you could have like age equals 30, and yeah, you're good with it because TypeScript infers age to be type of number. So, and this is what we called type inference. Okay. We have let's talk 5 generics. 5. We'll talk about generics. Yeah. So generics. Okay. Basically here, TypeScript allows you to create generic types and function that works with a range of data types. So for example, I will have, as I talked about it before here, the function identity. Like I can rename and re-add. Let's call it copy because we have identity, or let's call it yeah. Okay. So basically, you can just create this function and reuse it with multiple different types that you define for each variable. And we talk about generics in a bit. I guess we have advanced types. That's quite important to talk about. And we have advanced types, and in this one it will be basically TypeScript provides advanced types features such as map types, conditional types, and types predicators for creating complex type transformations and constraints. So for example, we have type we call read only, and this read only will have, like, let's give it this t that we love all. Okay, and equals, and I will say what's going on here. Duplicate. I have another read only. I will say read view only. Let's call it view only. And here I will say, okay, so it will be read only, for example. Yeah, delete this one. It will be read only for like K and P in type of T, T if or T. It's type of P. So maybe this is quite hard to describe. So let's just try to talk about this one. Quite give it time, because I guess in my opinion it's an important thing to talk about. So here the read only or the view only in TypeScript is a utilized type that allows you to create a new type where all properties of the original type T are marked as read only. In other words, it makes every property of T immutable, preventing any changes to their values after initialization. So this is the example. This is the example, and let's just try to discuss first T. T is a generic type parameter representing the original type whose properties you want to make read only. K, not K, sorry, P. P in key of T. So basically, this one is map type that iterates over each property of each property P of the original type T. we have here the read-only type T. This fold line is that specifies that for each property P in T, the property in the resulting type should have the same name, which is P, and the same type, which will be T of P. But with the read-only modifier. So basically, if you have, let's give an example for it. Let's delete this one and add an example for it. So, for example, let's just look at this example. We created a class here, a type called a mutable person, and this mutable person we have here created another type called read-only person, and we just pass this mutable person to it, and the mutable person will be the T. And we have person, it will be type of read-only person, which will give name called Alice and age 30. And when you try to rename or change the variable, it will tell you no, you can do that because cannot assign the to name because it is a read-only property. So yeah, it's quite important. Let's commit this one, and let's see where should we continue. I guess we have maybe we have two more. We have the type assertion, and type assertion allow you to assert that the value conforms to a specified type or overriding TypeScript. So for example, we have let's just copy this one. In which one here? We are in 6, I guess. So 6, and it would be 7 right now. Oh, will be 7 right now. So let's talk about type assertion. So basically, type assertion allows you to assert the values. Okay, I would love to put also the description because maybe you guys need to read it. And let's and let's just do it like that. I guess this way it will be way more better for you guys to read. And let's delete this one. So for this one, let's just try to know how this will work. So let's just create a function. Okay. Function. I will call it explain assertion, and okay. So I guess they did it. No, let's delete everything. So I will have a value of this value. It will be any, for example, and I will give it let length, and it will equals number, and it will be here value. No, not like that. Not like that. This could also work, but I don't want to describe it like that. So it will be value as string dot length dot length. So basically here, this is called a type insertion. We have number 9. We have let's call it nullable types. Let's call it 8, number 8, not 9. Nullable types, and this one will say TypeScript basically has built-in support for declaring with nullable types using the null and undefined values. Okay, so let's just try to give an example for it. So here I will just say let result will be string or null and equals null. I guess number last one, it will be, we'll talk about alias type. So we talk. Oh, we have a lot of code already. Okay, that's decent. I love that. Number 9, it will be alias type, and we will have. Let's just copy it like that, and we have this one alias type, and then just So basically, type alias allow you to create custom names for complex type and improve improving code readability. So for example, we have a type point 2 let's call it hoodie, and this one will be have, for example, color, which will be number, and it will have size, which will be number also. Let's make it number and number. We have also type declaration. Basically, TypeScript includes type declaration for existing JavaScript libraries and framework, enabling type checking for third parties code. Want to talk about this? We talked about the types. We talked about what is TypeScript. We have maybe more questions. Let's just see this one. One is that maybe you have here 2 more questions or 3 more questions. Is that let's scroll down, and I want to say, what are interfaces? And this is the in TypeScript, and let's just talk about the answer for this one. So in TypeScript, an interface is a way to define the shape of a contract on the object. It is a blueprint that describes the structure of an object, including let me type it for you here also. It's okay, it wasn't a good idea to copy it, because I guess if some of you will totally focusing with me right now, I guess he lost that focusing. But yeah, it should be like that. Okay, so in TypeScript, an interface is a way to define the shape of or contract of an object. It is a blueprint that describes the structure of an object, including its properties and methods. Interfaces are used to enforce a certain structure for objects, making sure that objects that claim to implement an interface adhere to that structure. So here, if we want to talk about, we want to define an interface. So basically, let's just talk about this one. Okay, let's call it trousers or clothes, for example. No, cloth, and just add this one here. And this clothes has, for example, has a color and size. Color, it will be string. Let's call it size, it will be number. For this one, we have, this is the definition for interfaces. Also, you can add, for example, get size, and it will be like a method, and it will be like a void. And yeah, if you don't know what this line is, let me describe it for you. So basically here, the say hello method signature you have seen right now indicates that it's a method that doesn't return any value, for example, or return. It's different here as indicated by the void return type. It in TypeScript, when you declare a method with a void return type, it means that the method doesn't produce a meaningful result or value. Instead, it's typically used for methods that perform actions such as displaying a message, updating a state, or triggering some side effect, but don't return data. Here, for example, let's just to give an example for this one. I will copy this example and show it to you guys. So basically here, if you can see this, this one is void. It doesn't return. It doesn't change anything. It doesn't return anything. We console log something. You know. Let's talk about the. Let me continue talking here. What? Oh. We want to talk about implementing interfaces, also how to implement an interface. So let's say that we have let's say that we add a class, and this class will be okay. I really love Copilot. It just doesn't do anything for you, everything. Let's call it a t-shirt. So for example, let's say this one here. So basically, classes and objects can be implemented interfaces by declaring that they adhere to the interface structure. When a class implements an interface, it must provide implementations for all the interface's properties and methods. Okay. So we have this one, for example. Okay, I didn't say what is this. This was called implementation. We want to implement for the interface. Let's talk about. We want to talk about object shape. I guess it's important to talk about object shape here. Let me scroll down, please. Oh, thank you. 3 object shape. This one, let's just try to interfaces can be used to describe the shape of objects. When you create an object that adheres to an interface, it must have properties with the same names and data types as we can see. For example, let's just create this person. Let's just take this person or the cloth or whatever. So for example here, if we want to create something, it should be exactly the same. So basically, we have, let's call let, let's call that, let tank top, and it will equal, it will have, it will be type of cloth. And yeah, it should, because it's not in, it will be type of cloth, and so basically it will be have a name and a color. It will be red. Maybe we'll have a size, which will be 23, and because it's red here because it is property get size is missing in this one, as you can see, and the other one tank top is unknown word. And yeah, so let's add the other one. It will have a get size. Let's just copy this one. So get size, it's a void, so it doesn't return anything. So it will be console.log hello, for example. So yeah. And let's continue. Maybe before we want to talk about the optional properties, because we have optional properties. So let's just basically optional properties that, let's go here. We can add a new property called style, and it will be a number or like string. Let's call it string. And as you can see, when I just edit, you find the tank top here is red. And if we scroll about it, they say the property style is missing in that type. If I make it optional, like adding this one, that means it's gone. I will have, we have read only properties. So let's just add read only one. So basically we have let's like x will be read only here, for example, and let's make it optional also. So basically I have read only here. So basically when I try to make y, which equals what was it? Its number? Yeah, 3. If I try to make it modify tank top dot y equals 544, it say cannot assign to y because it is a read only property. We have extending interfaces. So basically I have Claude right now. I could create another interface and extend it. So for example, I have Claude. I could create another interface. I could create another interface, and I call maybe what something will have color, size, and style. Let's call it furniture, or let's find something that's quite let's say material, and it will extend the cloth, and basically I will add maybe material will be string. Basically here extending interfaces can extend other interfaces, allowing you to create new interfaces that inherent properties and methods from existing ones. I guess that's it. I guess this is the best answer for this question. How many questions did we do? Like this is one, and this is what are interfaces? Only 2. Okay, we have 3 more. I guess it will be a long video for you guys. Sorry for that. Let's to code about what are generics in TypeScript. Generics in TypeScript. So basically, generics in TypeScript provide a way to allow you to create reusable blocks. Okay, this is right or not? Let's see. TypeScript reusable. Yeah. Okay. I guess Copilot is pretty decent, but it's quite good, but it's not perfect answer. So basically, generics in TypeScript provide a way to create reusable type-safe components by allowing you to define types or functions that work with a variety of data types. They provide the ability to write code that can adapt to different data types without sacrificing type safety. So I guess I'll try to copy this one, because this one is, in my opinion, is better. I could, where is the store? I want the store here. No. Okay. Let me try to here. Yeah. I'm trying to put all the comments here because I guess I will push this one to GitHub. And maybe you can view it, guys, if you want. Let's see. Okay. Okay, so let me, I guess this one is quite better. Okay, that's great, guys, that's great. So first we have generic types, not generic functions, generic types. Let's talk about them first. So generic types, basically you can define a generic types by using angle brackets, which is, I will show it to you, angle brackets and type parameters within your type or function declaration. So basically, let's just see how this will work. So basically, I'll create a function called identity check, for example, and it will have basically here, as you can see, like you can define a generic types by using the angle brackets, which are these brackets, angle brackets, we call them angle brackets, and a type parameters within your type function declaration. The type parameters acts as a placeholder for, this is a type parameters for a specific data type that will be provided when the type or function is used. So if I created const call the result, it will equals identity check. It will be, for example, string, and it will be this hello world, and basically we will return it. If you try to have a result and pass to it something different than string, it will return you an error. We want to talk about the basically here in this example, as you can see, before the previous example, just here t is a type parameters that represents the data type of the argument, and it and the returns value of the identity check function. We have a generic function. Okay, back. Sorry. Let's call it generic functions. So basically, the generic okay, it was a good chance for me to compile it, but this was not what I need to know. So basically here, functions can be also be generic. You can use type parameters to specify the data types of functions arguments and returns value in a flexible way. So for example, I'll create a function that called a pair, and this one I will give it to t and u as a generic, and okay, and basically here let's call it first and second, or let's make it a and b here. So basically, if I want to say it like const number and string, for example, so pair, it will be 1 and 2, and I will specify t and y here. So it will be a number and string, as you can see here. So basically here, pair is a generic function that takes two type parameters, t and y, and representing the types of its arguments, and it returns the value and enters in the value. Let's talk about generic classes. Generic classes. So basically, you can create a generic classes within type parameters that allows the class to work with the different types. So basically, if you can say like class box, we have t. No, not like that, please, not like that. T, and I will say it will be Bix, not Bix, box, man, box, and it will be have a constructor, and it will be like private, for example, value and t, and we'll say get value, and it will be also, let's just give it t, and here we will say return this dot value, and I will say const number box, and it will equals for example new box and its number. So basically for this inherent for this instance, any return value could be any parameter should be number. So if you pass string, it will not work. Last we have for we have the generic constraints. So basically you can apply constraints to type parameters to restrict the type that can be used. For example, you can use you can ensure that a type parameters extends a particular base type or a specific properties. So let's just copy this example. So for example here, as you can see that we created a function and we give a generic type and it will extend the length will be quite number. It's quite important to know that. And we have args and the long length, it will be a string, and this will be valid. Otherwise, if we post a number, it will be wrong. So in this one, here's t is constrained to types within a length property. So yeah, that's it basically. And maybe we could I guess that's it for all the generics. So basically generics in TypeScript provide a way to create reusable type-safe components by allowing you to define types or functions that works with a variety of data types. They provide the ability to write code that can adapt to different data types without sacrificing type safety. And that's it. This is the third one. We have maybe two more. We want to talk about we talked about generics. We talked about interfaces, and we talked about what are types, and we talked about what are TypeScript. I guess it's good to talk about I guess it's good to talk about classes in TypeScript, because the next questions, it will be we will try to compare most of them, but I guess the classes in JavaScript. So okay, basically let's try to talk about what are classes in TypeScript. What's going on? What are classes in TypeScript? So basically, in TypeScript, as in JavaScript, classes are fundamental features for creating objects and organizing code in object-oriented manner. TypeScript classes built on the concept of classes in JavaScript, but it introduces static typing and other enhancements. So basically, we want to create a class. Let's create a class. And I will call it I guess I have already class with name person class, and I will call it okay, it doesn't make any problem here. So let's just try to do, and I will give it we have a constructor here, and the constructor you can define a constructor method inside the class to initialize its properties when an object is created. We have properties, and the properties, as you can see here, you can declare properties on class specifying their types. So I'm creating types here. We have methods. For example, I will create a method here. Let's just copy this method. We have this method here. And basically here you can define methods on the class, on any class. So basically this method, it returns hello, my name is this name, and I am this age. Like maybe if I put the name Muhammad, so hello, my name is Muhammad, and my age is like 32 or 27 or whatever it will be. So my name and I am 32 years old. We have the accessing modifiers. So basically, TypeScript allows you to use access modifiers like public and private. So for example, we can make one private and one public. So for example, we have name and age, and they are quite public and private, and we have string and name, and we have this dot name and this. And name is declared, but its value never read. Yeah, that's right. Why it's not read? Name and age, and return. I guess. Give me a minute. Let me try to do it. Yep. So yeah, these values are private. You can't use them. And also we have inheritance. We can TypeScript supports the class inheritance, allowing you to create subclasses that inherit properties on methods from other class. For example, I could create a student, and the students will will uh, um, will inherit the whatever person has, and we create a new one for it. So what was it? So that it does not exist on student. Yep. Yeah, it doesn't exist. Okay. And we have also interfaces. You can implement interfaces in classes, and leave it anyway. Leave it for now. We will talk about why this error is there and how we can solve it. But this has a specific video for it, so I will not solve it now. We have the static members. You can define the static properties. For example, let me copy this one for you guys. So basically here you can define static properties and methods that belong to the class itself, not an instance of the class. And by this way, by this one, for example, if you want to add if you want to add the username, you could try to edit it as a static one. We have the abstract class. TypeScript allows you to create abstract class which are meant to be subclasses and cannot be in a station directly. And yeah, so that's it. I guess this is 5 questions, right? Or what? Yeah, I guess this is 5 questions. This is 5 questions, and I will try to I can't assure that I will do that, but I'll try to do it, because guys, I guess it will be quite good for you to look at these problems. And I'll try to push it at my GitHub account. And yeah, so yeah, that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you guys in future problems.